everybody's like, where are we going to get electricity? Where are we going to get electricity? We have a really excellent option just already here.
We are facing a glut of used EV batteries, and that's at the same time we are in an energy crisis as data centers and other users are gobbling up power. But now some clever entrepreneurs have figured out how to take one of those problems to solve the other. They are repurposing electric vehicle batteries to provide affordable, climate-friendly electricity.
Welcome to Positive Charge, a podcast highlighting planet-saving technologies sponsored by Amazon Sustainability.
I'm GeekWire reporter Lisa Stifler.
And I'm Laura Scott, an audio producer and journalist. In this episode of Positive Charge, we travel inside Moment Energy's brand new production facility in British Columbia to see how retired EV batteries are being resurrected into mega batteries that bring power to local grids and electrify off-grid homes and businesses. We'll talk to battery pioneers at Redwood Materials, we'll talk to data center heavyweight Crusoe, and we'll ask a battery geek to answer a critical question. Can yesterday's commute power today's AI boom and our clean energy future?
So first, let's talk about batteries for a minute, because this technology has evolved so much in recent years, from massive grid applications down to their roles in our daily lives. So how are you, Laura, using batteries? Do you think about them ever?
Well, I guess I always thought about batteries as something I would put in my TV remote or my smoke detectors, but the idea of batteries as something that you bring with you to continue to power whatever you need them to on off-grid has really come into my life more, even in the past, I would say 2 years, as someone who loves camping and hiking. I love to have remote battery packs, and they can power my phone over a long camping weekend where I might not be able to, sit by the one, outlet in the bathroom at the state park and I desperately charge my phone. Mm-hmm. I brought one to Coachella to put into my phone so I could walk around and check in with friends and make sure that my phone wouldn't die. So yeah, the way that I've used batteries has changed pretty dramatically just in the past few years.
Yeah. And so what we're really talking about is that concept kind of writ large. So first, let's check in with our battery geek. This is Grayson Shore, Executive Director of the Pacific Northwest Battery Collaborative.
Batteries are perhaps the most important technology of our time. They're amazing. I mean, throughout humanity, it's all been about generating power. This is the first time that we're talking about how do we store and bottle that power and move it around. We've been working with water all of humanity, and now we've figured out the water bottle. That's what energy storage is.
And that energy storage is more important than ever as we move away from fossil fuels like oil, gas, and coal, and we turn to solar and wind, which have become super cheap, but there's a hitch. The sun doesn't always shine and the wind doesn't always blow. So just as Laura uses her battery pack when she can't reach the power she wants, the electrical grid or a house with solar panels, they need batteries too when the clean power isn't available. And not only that, the batteries increase the overall capacity of the grid.
And these are some of the needs that Moment Energy is trying to meet. You could say they're trying to meet the moment. The startup was founded in 2020 by 4 friends who attended Simon Fraser University up in British Columbia. They were engineers in mechatronics, which is essentially robotics, and they'd previously launched a startup that developed a mental health device that used neurostimulation to help people get into a mindfulness space. That project went well, but they didn't feel like they could go the distance with FDA approval and the rest of it, given their backgrounds, which were not in psychology and mental health.
But then they knew that they made a really good team and they wanted to have a positive impact. So they started thinking about other things they could do and landed on the idea that EV batteries were reaching the end of their lives. And they were also looking at these power constraints. And so they teamed up again to form Moment Energy. We visited their new 100,000 square foot facility, 5 times bigger than the space they were in. This is a building that was an empty shell, and they've created offices, their lunchroom, complete with a ping pong table, a huge manufacturing space. And they did this all in the span of just 6 weeks because they are scaling fast to meet crazy demand. We took a tour with Eddie Chang. He is the co-founder and CEO of Moment Energy. And we'll let him explain what they're doing.
For the listeners out there, the difference from repurposing and recycling is repurposing is when we take a battery pack and then we test the battery for quality and then we assemble it into stationary energy storage. And if you came onto our manufacturing floor, you'd actually see these beautifully, 3-foot long rectangle esque batteries, and they're kind of just racked up, right? And they're repurposed. Versus recycling is you take that same battery, but you grind it up into this black gunk. Like we call it a black mass, right? And then ideally after that, you have to go to a refinery, extract the lithium out, the cobalt out, all the rare earth minerals out through another refining process. And just culturally, we had always been taught, reduce, reuse, then recycle last.
All right. So I like putting you on the spot in these podcasts. Tell me, what did you think of this new space that Moment is building out?
The space just feels brand spanking new. You can smell the drywall and the paint. But the main feature of this facility is this giant manufacturing space. I mean, picture an empty Costco. And I'm sorry that Costco is always my point of reference on this podcast. But picture an empty Costco. It's this giant space that is mostly empty. I mean, if you dropped a wrench, which happened a few times for the guy who was building the shelves, it really just clangs and echoes. And you'll probably hear a little bit of that echo in Eddie's voice as he shows us around. He was like a kid in a candy store. You're pointing here, that's going to go there. You can just see that it's all in his mind what this space will become in just a few more weeks.
They are anticipating all this growth, so they're going big. All right, but before we get into explaining how this reuse process works, I have to do a quick lesson in EV Batteries 101. So the smallest component are cells. So these are just like the AA and AAA cells that you use for your own devices. That's one version of a cell. They also have something called a prismatic cell. That's kind of a solid block that's kind of like, it looks a little bit like a military canteen. They also have cells that are in pouches. They're kind of soft, this aluminum laminated case. I kind of think about it looking like a Capri Sun pouch, sort of, but much higher performing. And so basically you've got all these cells, and those go inside modules. Hundreds to thousands of cells go inside modules, and then multiple modules are assembled inside a pack. And a pack is like the big metal box, kind of a shell that holds the whole thing together. And that is what makes up the EV battery. And so these packs come in all different shapes and sizes.
Yes, and every car company has their own proprietary formation of those battery packs. At Moment Energy, Eddie showed us a table where they've laid out examples of 4 major car company battery packs. He actually couldn't tell us like specifically which one goes to each car company because technically this is all, again, they safeguard this information about how they're distributing the weight of a big heavy battery pack inside the shell of the car. But it was pretty easy to guess. Mm-hmm. And we were given some nice little hints.
So I can't name all the automakers, though I named one of them. But essentially what we're currently looking at are 4 different battery architectures, and they will span the bottom of every EV. Of course, we actually have pretty much batteries from every single automaker, which is exciting. We're looking currently at a battery pack that spans the entire floor of the vehicle. That's how long they are. Like if you had a portable battery pack for your phone, it kind of looks very similar to that. But what we're also looking at is between every EV, it's a little bit different.
Yeah, I mean, basically these packs are kind of under the floorboards of EVs. Like the Tesla pack, it runs kind of along the entire bottom of the car, more or less. So they can be like 7 to 10 feet long, like 5 or 6 feet wide. They're huge. These things are huge and heavy.
Super heavy.
Yeah.
And as the opening of the episode hinted at, these batteries have a lot of life left in them. All of these are batteries that have been officially retired from cars and sent to Moment Energy to be repurposed. But why are they facing early retirement?
So what happens is the batteries degrade over time. They charge more slowly. You can drive fewer miles. And then they kind of reach a dropping off point where they're really not usable anymore in an EV. Here again is Moment Energy's Eddie Chain to explain why.
Our kids won't understand it, but back when we were younger, how Christmas lights used to work. So back in the day, you had a string of Christmas lights. If one light bulb burnt out, the whole string burns out. Engineering perspective is they're in series. And until you swapped out that dead light bulb and you put in a new one, then the string turns back on, right? And that's what's happening in the battery pack. The actual failure mode for EVs is actually due to a single cell failure like that light bulb, where you have a battery pack that spans the entire floor of your vehicle. We're going to go look at a couple of those battery packs. We can open it up, And what you would see is 8 beautiful modules. They're kind of 3 foot long. Every automaker is slightly different. And then within each module, they could have up to 148 battery cells in them. Now what you've had is one cell within one of those modules that's died, and it kills the whole pack. So what we then do is you open up the battery pack, you find the one dead module, and that's the one that we recycle. The remaining 7 modules actually have closer to 90 to 95% life left. We say in the industry 80%, but it's mainly because we rather under-promise, over-deliver. But anecdotally, we've been getting batteries closer to 90 to 95% life left. So again, like if you're telling me we should go and recycle or dump these essentially new batteries, like why would you do that?
So here is the process. When they actually get these batteries, what happens? They take a healthy, non-damaged, can't be in a car wreck, EV battery pack from partners, and they are working with like Nissan North America or Mercedes-Benz. And depending on the source, they can get the batteries for free or for much cheaper than buying new Chinese batteries. They said they're like 9 times cheaper. And so then what they do is they take that battery and they perform an intake test to ensure that the batteries are actually safe and to see what kind of life that they have.
If you have 2 batteries that are both 90% life left, they're usually not equal. So you drive a Nissan Leaf in Arizona versus Alaska due to temperature alone, let alone maybe you have a grandpa that barely drives their vehicle over 20 years and you have some hotshot that supercharges and abuses their car every day, and they both got to that 90 or 80% life left. We actually, through our battery science algorithms, like we've actually found that is very different in terms of lifespan.
And then they disassemble the battery packs to the module level, and they remove underperforming modules, keep only those that are performing well and meet their thresholds.
So basically they pluck out the Christmas light that is ruining the whole string.
They pluck out the strand of the Christmas light because it's the module contains multiple cells. So they just take that module out. That string is done. But then the rest of them will work. So then you'll have enough assembled modules that everything works happily. And then Moment has this special AI technology that can regulate the output of the different cells because as cells age, their voltages begin to vary. And so what they need to do is kind of balance that out, where you put more energy into the strong cells and you take energy away from the weak cells, and that gets a higher performance. And they take the modules, they assemble them into racks, and those go into, so instead of like putting it into packs, they go into racks.
Nice.
The modules go into racks instead of the EV packs. And the racks go into these steel containers. They've got HVAC systems in there to make sure they stay cool.
They basically look like shipping containers.
Yeah, of different sizes, exactly. And these systems are supposed to last up to 30 years.
We actually got to see one of those systems. It's about half the size of a shipping container, painted all white. This is Moment's Luna modular system. Here again is Eddie.
As we get a little bit closer here, this is our half Luna unit. So this is our 400 kilowatt hour unit. We're totally sold out, which is exciting. We've deployed a lot of these across a lot of applications, such as at Vancouver International Airport. Their entire vehicle fleet is electric, but the problem is they want to install 5 EV chargers. And when they want to install 5 EV chargers, the local utility says, hey, you're going to have to spend upwards of $20 million to upgrade our power lines, upgrade the transformers, right? That's crazy. So instead, they bought a couple of our batteries. These batteries charge at 3 a.m. And then around 12 p.m., that's kind of when you've made your morning deliveries or you've used that truck. The truck drivers now, they're taking a lunch break. They can fast charge. So really quickly, level 3 charge their vehicles in like 20 to 30 minutes.
They can also make the Luna in 1 megawatt hour blocks. So to give some perspective, a 1 megawatt hour battery system would fully serve about 49 Seattle households for an entire day, like a 24-hour day. And they actually have a new and improved system coming online soon. They haven't officially announced it, so we really can't talk that much about it, but we did get to have a little sneak peek of it. They brought it out on a forklift, and we're kind of spinning it around in their parking lot in the sunshine to do a little photo shoot as this news will release.
I don't think we were supposed to see that, actually. But.
No, actually, I was trying to back out of the parking lot, and they had to wave me the other direction.
But there it was, the new improved version.
Spinning in the sun.
That's right. And so and these units are being used in so many cool applications. Eddie mentioned that these have been deployed at airports, and other customers that they're working with include hospitals, the Canadian Department of National Defense for like a humanitarian operation, other industrial facilities, and one that they'd mentioned on their website I had to look up. It's called God's Pocket Resort. And it is the most beautiful little eco lodge. It's on this teeny tiny island at the north end of Vancouver Island. It offers scuba diving and sea kayaking and has all these little tiny cabins on these docks in these bright colors. And they have bought one of Moment's early systems to help replace some of their reliance on diesel generators.
Eddie will explain how Moment Energy's batteries can pair up with an existing generator.
That generator used to have to be on for 24/7, right? Because it had refrigerators at a home or whatnot. Now what happens is generators are only on for 2 hours. Our batteries are charged up. It distributes energy to the rest of the home or whatnot for those 2 hours. It turns off, and then our batteries last for 4 days.
And so having one of these Moment systems really optimizes and stretches out what the diesel generators can do.
But away from God's Pocket on a tiny remote island, these systems are also scaling to serve big operations like data centers. And that takes us to another battery repurposing company, Redwood Materials.
First, we're going to take a quick break to hear from our sponsor, but when we come back, we will dig into Redwood.
Welcome back to Positive Charge. Moment Energy isn't the only company out there that's repurposing batteries from electric vehicles. We talked to another top player in the industry, Redwood Materials.
So Redwood began almost a decade ago, and it started as a battery recycling company. It was launched by J.B. Straubel. He was a Tesla co-founder and former chief technology officer, and he saw the coming bottleneck in critical raw materials for battery production. So Redwood began taking batteries from cell phones, laptops, tablets, e-scooters, e-bikes, as well as EVs, and recycling them. But over time, Redwood's leadership realized that these EV batteries in particular still had more to give. So they created a division called Redwood Energy.
Here's Colin Campbell, Chief Technology Officer at Redwood Materials.
I think it was almost an accident. We had a group of people standing around watching our recycling operation, looking at these giant battery packs that were going to so much effort to disassemble, and just wondering, like, can we do more with these before we shred them? Like, they're perfectly good. It seems like a waste to just go ahead and shred them. And it was really just that insight.
And now 95% of the EV batteries that Redwood is receiving are being repurposed instead of mushed up into black mass. Part of the drive for the move into reuse was a timing issue.
We launched this last year because it was really the first year where there was enough supply of lightly used batteries coming out of the electric vehicle market. So I like to think of us as we are just the EV market 10 years shifted. The Model S maybe can claim to have kicked off the EV boom in the US, roughly 10, maybe 14 years ago now. And those batteries are just now reaching the end of their first life. And we're just now starting to see the ramp of supply of used batteries.
So they have a similar approach to Moment. They take a battery pack, they determine if it's suitable for reuse or recycling, and if it can be reused, they run an assessment test. It takes about 1 to 5 minutes to figure out the battery's health. But they take a much lighter touch when it comes to managing the performance.
Most of the battery packs, they are incredibly robust. And if you just don't mess with it and you leave it alone and you use the functionality that those car manufacturers already built in, you can handle any sort of aging aches and pains that these batteries may have without any extra effort. One way that I like to think about it, Second Life energy storage site, is an electric vehicle parking lot with the wheels removed. So it's just literally the battery that was in the car. There's lots of them arranged in a grid together and plugged in. Like that is all it is. They already do this. The batteries are already made to do this. I can't emphasize enough how gratifying that is in this moment of like load demand, and everybody's like, where are we going to get electricity? Where are we going to get electricity? We have a really excellent option just already here.
So what happens if a component of a battery pack isn't working? Do they just toss it?
No, if the company does find that a module in a pack is underperforming, they can repair it, they can replace it, and they warranty their systems for like 20, 25 years. And look, even though Redwood was created by Tesla veterans, they can work with all of the automakers.
We can take any battery from any manufacturer, and the core piece of electronics that we've developed internally with our power electronics team, which we call the universal translator, can take any battery from any manufacturer. It can speak a Tesla language, a Rivian language, General Motors language, whatever vehicle you might have, and translate it both in the way that it sort of talks logically, but also the voltage and the power and the chemistry differences between those packs.
Redwood is newer to this mission than Moment, but they are moving so fast. In June 2025, the company unveiled the world's largest microgrid powered by solar and Second Life EV batteries. This project was specifically designed in partnership with Crusoe, which describes itself as an AI factory. So this company does everything from sourcing the energy for a project, designing and building the data center, and they run their own cloud computer services. The partnership with Redwood was for a facility in Nevada. This pairing of solar and repurposed batteries allowed it to bypass what are called interconnection queues. That's kind of a fancy way to say just waiting to get hooked up to the grid. And it avoided using diesel generators as its power source when the sun's not shining.
It's hard. I mean, power is now the binding constraint on AI.
Here's Scott Williams, Vice President of Energy at Crusoe.
The challenge is really, how do you wait for the grid at this point? And the utilities, while they're trying to do their best to keep up with the demand that's going on right now, traditional development, we follow the grid, and the interconnection queues are now stretching for years. And they're deciding whether AI projects happen at all.
Given those delays, Crusoe is now all in on repurposed batteries.
We've been able to avoid kind of the two most expensive things in traditional development, right? Which is the multi-year grid interconnection and then the cost of building new storage systems. So the Second Life batteries, repurposing these packs already exists. They're cheaper and less resource intensive than new batteries. And on-site microgrids beat a new grid connection or diesel on both cost and speed. And so we are seeing that this is cheaper, quite a bit cheaper than having, diesel. We've signaled to Redwood that we're going to grow with them for a couple, multiple gigawatt hours paired with our modular units, which is super exciting.
This is, I think, the most geeked I've seen you about any episode we've done so far. What is it about batteries that lights you up inside?
Batteries are just amazing technology. They are so versatile and so powerful. And so this use of these gently used EV batteries seems like such an obvious fix for this problem. But there are some challenges to making this happen. First up is safety concerns. Last year, there was a really big fire at Moss Landing, this battery-powered facility in California. Some nearby residents had to be evacuated. It burned for 5 days.
Whoa.
I know. And in the wake of that, there are communities that are protesting against planned installations. They are seeking policies to prohibit new facilities.
So is fire danger the biggest thing that we have to worry about when it comes to sort of a remote battery storage unit? Is that the biggest issue?
Yeah, they're worried about safety, what goes into the air, what could go into their water. They're scared. But Moment and Redwood say they have robust industry certifications to ensure that their technology is safe. Most importantly, the fire that happened was with older batteries, and these were not former EV batteries. They were stored together in a building where the blaze was able to spread, and that is not what is happening with these kind of next generation companies. So Moment has UL certification. This is really like the gold standard for its facilities and devices. Redwood has some of the UL certification as well. Moment uses these steel containers to shield these devices and kind of keep them separated. Redwood deploys them in a very spaced out configuration.
Here's what Eddie Chang at Moment Energy has to say about EV battery safety. He was very passionate about this topic.
These batteries that we're repurposing have literally gone through, again, I would not tell listeners to do this. Please do not do this. But theoretically, if you drove your car into a wall at 200 miles per hour, it should not combust. And that's the type of safety that these batteries have gone through. And the automakers have done a really great job in making them safe, which is why when we then repurpose them, these batteries are actually better than new lithium stationary storage applications that the Chinese make because these have been over-engineered for safety.
That said, he does have worries about competitors who might not be as rigorous in their approach. And Colin Campbell said Redwood is working with UL to develop certifications specifically for the reuse sector.
All right, so in addition to the safety concern, there's another challenge to making this technology scale up and get deployed everywhere. So Grayson Shore, he's the Pacific Northwest Battery Collaborative guy we heard from at the top of the show. He's also a co-founder of a company called Buckstop, which is focused on circular economy. So like really the recovery of all these valuable materials.
Oh, so they stay in the same circular loop, and then we just get to keep using them over and over.
Exactly. That's his whole jam. And what he is concerned about is the availability of batteries for reuse. Because what happened is the recycling industry got set up before reuse did. And they don't want to let go of this raw material. They predate reuse. They've got some real heavy hitters. And there are more policies here that are in place to actually require that a certain percentage of batteries are recycled in order to keep them out of landfills. Here's Grayson Shore.
They're competing against an extremely cutthroat recycling industry. The recycling industry has built more capacity than the number of batteries coming through to recycle. So you have an immense amount of people competing for a comparatively small amount of material. And at the same time, you have laws like the EU law and some laws in the US that require a certain amount of recycled content in new products. Really well-intended policies, really bad outcome. The policies think, hey, if we require a minimal recycled amount of content to be in new batteries, it's going to force people to go and collect those batteries and recycle them and put them into the new batteries. But it incentivizes recycling over reuse, which therefore actually takes something that could have been reused and actually benefited the economy and nature and the climate longer, and brought it right back, destroyed it, and put it into its raw materials, and then brought it into a new product. And so the recycling minimal recycled content laws are actually undermining the ability for the reusers, remanufacturers to grow their businesses.
I don't know. I always thought like reduce, reuse, recycle. I thought the reuse and the recycle part were kind of the same thing, but it turns out there's actually a really big difference.
A battery is the most carbon intensive, typically almost always the most carbon intensive component of whatever is using that battery. If it's an EV, if it's a pair of AirPods, it's your cell phone, that battery will constitute somewhere between 30 to 60% of the carbon footprint of that equipment or whatever it might be, that asset. So from a climate perspective, repurposing a battery as opposed to recycling it certainly has better environmental benefits to it, because you're squeezing out if you're at 70% or north of that, even sometimes less than that, you still have a lot of life left in that battery.
Moment Energy is charging ahead despite some of these hurdles. In addition to that brand new 100,000 square foot facility that we watched getting built up in British Columbia, the company is also building another even bigger facility in Austin, Texas. It calls the BC site its mega factory, and the Texas operation is its gigafactory. It's supposed to be up and running by January. Bottom line, Eddie Chang is bullish on the future availability of batteries.
Like to power the city of Denver, for example, you typically need like 2 to 10 gigawatt hours, right? Depending on usage and what time frame we're talking about. To put in perspective, today there's about 200 gigawatt hours of battery supply out there. Moment Energy has access to like a lot of it. And we're constantly, every single day, people are trying to ship off a ton of batteries. To put in perspective, by 2030, which is actually not that long from now, right? There's going to be 953 gigawatt hours. What is that? So I can power Denver 90 times.
So again, while there's competition with recyclers for these batteries, Eddie says there is enough power in the used batteries available today to match the electricity use of the city of Denver 20 times over. And in 4 years, that keeps going up. In 4 years, the battery supply will equal 90 Denver's worth of power. So Redwood said they could not share specific information on its new partnerships, but Colin Campbell said that last year was the first in which they were really able to have enough batteries to do this sort of utility scale deployments. And they expect to keep growing year over year over year, well into the future.
Sounds like these two companies are really in kind of a breakneck race with each other.
Yeah, a little bit. I mean, there are a lot of batteries out there, supposedly. It depends.
So there's enough market for both of them?
Oh, yeah. The demand would certainly be there, I think. It's just a matter of getting the batteries, stacking them up and sending them out. Yeah, I mean, I love the simple elegance of this solution. It just seems so smart. What are your thoughts? What was your takeaway on this?
Yeah, it's a no-brainer. You know, one thing Eddie was telling us is when we recycle batteries, some companies send that black mass of material back over to China for refining. And then we have to buy it back from China again, either as new batteries or as raw materials. Again, I always come down to one of the biggest complaints about climate tech is that it's more expensive and it's an extra step. And this actually saves us money in the long term, right? We're keeping things in the country that we don't have to purchase back, and it decreases our reliance on a foreign entity of concern.
Yes.
Which China is often called.
Yeah, absolutely. And another one of the benefits of this process is, you know, if we're able to put most of these batteries back into reuse, we can keep perfecting the recycling component to make it more efficient for when they ultimately really do die in another 20 or 30 years.
Yeah, buying us 30 years is not nothing. I mean, I could buy one right now that would power my neighborhood until I'm 60 years old. That's crazy.
I like that. You should kind of put out a sign and see what you can kind of crowdfund.
Crowdfund it. We should go in on that
Yes.
together in Eastlake.
Yeah, like get a Luna.
One of the things that I found really interesting about this battery conversation is that it really ties into all of the renewables that we've explored on this podcast. So, you know, Susan Sue was telling us about how great innovation in solar is at Pacific Northwest Climate Week. Fusion is something that could generate energy, if it works, that could be stored in these batteries and power the data centers that we were talking about in this episode. So if you've missed some of those earlier episodes and you want to learn about the promise of fusion.
Ooh, I've got one. I've got a connection too, because you are resurrecting you're resurrecting the batteries. And we did an episode on composting people. So that's kind of like, I mean, you're turned into soil, so that's kind of a resurrection. I don't know. Maybe that's religiously insensitive. But that idea that there's a second life for people as compost.
As microbes,
as soil. Maybe that doesn't work. But you should check out these previous episodes nonetheless.
They're all so good. If you want to hear any of those episodes, hit subscribe, hit follow.
If you want to drop us an email, we would love to know what you think about these episodes. You can reach me at lisa@geekwire.com. I promise to share the messages with Laura as well. And thank you for listening to Positive Charge by GeekWire, sponsored by Amazon Sustainability.